Hi, everybody, and welcome back to Chee-Tash. My name is Chris, and today we're going to be talking about Eloquent JavaScript, going on to Chapter 3, all about functions. Super excited for this one. Thank you guys very much for being here. If you guys remember last time when we did Eloquent JavaScript, Chapter 2, what did we talk about? We talked about a lot about loops. We went over the for loop, the while loop, the do while loop. We went over conditionals too, if, else if, else. We talked about switch statements too. We did a lot last time, and today we're just going to keep on building onto our JavaScript knowledge with functions. And you've probably seen me use functions in the previous videos. So today we'll learn a little bit more about them and some stuff that I never really knew about functions when it comes to JavaScript, at least. Some surprising things that I learned in this chapter. With having said that, let's just start off. Let's just hop right into it. Again, I wish there was a better way to show you guys the PowerPoint and the coding environment. So hopefully you guys can see the PowerPoint on the right. Maybe when it comes through on the video platform, it shows a little bit better. But yeah, let's kick things off, guys. Marjan Haverbeek starts off by defining what a function is. So a function is created with an expression that starts with the keyword function. A function is going to take in parameters, and it's going to have a body that outputs something, a body that contains statements that are executed when the function is called, because it's not necessarily going to output something in the way that JavaScript means output. Yes, a function can produce something, but it doesn't return anything. So there's a difference, and we're going to talk about this, how functions can have side effects or they can have products, or maybe not products, but they can return values. Slightly different. So if I have a function that prints something, the job of the function is to print something, that's a side effect. But if you use this return keyword, your function is going to return that value so that you can then assign the function to a binding. You can bind it to something because it's returning a value, right? It's returning a string, a number, a Boolean. We're going to take a look at this in a second. Let's move on to the next slide. So, yep, right here. Producing values and side effects. So return statements cause the function to produce a value. And other times, like the second bullet point says, sometimes functions can affect your program, but they don't return anything. And like I said, maybe it just prints something. That's a side effect. That's a side effect because it's not really, you're not using it to, how do I want it? Because it's not that a side effect it's an effect on the outer code, right? But it's not necessarily used to like change really sort of anything. It has like a touch, but the rest of the code doesn't really notice it. Maybe this is a bad job of explaining it, but that's kind of how I think about it. It does something, but the rest of the code doesn't notice it. But when you return something, the rest of the code could potentially notice it, right? It's the difference between being tapped and being pushed, if you like that analogy. Last bullet point there, a return keyword without an expression after it will return undefined. So a function without a return also returns undefined. So let's write a function. And like it said, every function, well, and there's different ways to write this. We're going to talk about this in a few more slides, but starts with the function keyword and then the declaration. This is kind of like a binding. This is like the name of it, right? And then you have the body, which is in between the curly braces. You have any parameters or inputs go in between the parentheses. And then anything in the body, this is where you have statements that execute. So I don't know, let's just say return, right? This is legal. Let's console.log sample declaration, bring in the parentheses, returns undefined. All right, so that's what that does. And then a function without a return will also return undefined. So maybe we just have like a simple local binding in here. What happens now? It still returns undefined. So remember that a function that doesn't return anything will return undefined. So when you go to call it or when you go to assign it to something, you know, like let's say let assignment equal sample declaration. Oops. And then maybe you want to do this. What should this print? Oh, print's undefined. Okay. So why, well, before I go on to the next slide, why do we use functions? I know in Java we use functions all the time. Methods that are functions that belong to a certain class. They kind of help break up the code, and instead of doing everything kind of top down, line by line, each by each, you can split it off into functions that you can have in other files like other .js files or like towards the bottom of your code. And it kind of helps to split up the logic or whatever you're trying to execute. It helps to kind of split it up. And you can give these functions names that kind of describe the job that they're going to perform. So it helps make your code a little more clearer, cleaner. So that's kind of like how I think about what I think about when I write functions. Like what can I kind of split off, or what can I write here? What kind of function can I write here that can help me perform the same job but make the code a little more simpler, essentially. Next one, bindings and scopes. So this is important to consider in functions. And you guys will remember when I wrote this while loop. I'm going to delete this. Do you guys remember when we were doing loops last time? And well, counter is less than 10. So I had this counter outside of the loop, right? I had this counter outside of the loop. And this essentially is something that you could write, and it would be way more clearer in a for loop. Oops, I forgot my incrementer. Counter plus plus. There we go. I might have to refresh. CodePen, it gets very feisty sometimes. But so when you have the counter in a while loop, you can it kind of functions as a for loop, but the counter has to be declared, instantiated outside of the while loop. Because if you do it within the while loop, it has a local binding. Every time the while loop runs, it's going to reset that let counter equal to 0. It's going to reset it to 0 every time because you're calling it in instantiating and declaring it in the while loop. So every time it runs, it's going to set it back to 0. So you have to set that global variable outside the while loop. There's a local scope that's in the box of the while loop, but the counter variable is outside of it, so it can be called. It can be called inside the while loop. So luckily I copied and pasted this. There we go. Let counter while. Why isn't this? There we go. Oh, that's why. I'm sorry, guys. I'm in the HTML section. Here we go. I was like, why isn't it highlighting? There we go. Okay. So it prints, 0 through 10. Now watch. Watch. If I was to put this in here, what's going to happen? What's it going to print? How about if I do this? Okay. How about if I do this? Zeros. Right? Does that make sense? Like, the scope here, okay, so yes, counter initialized at 0. 0 is less than 10, it's going to enter the loop. But then let counter equal to 0, it's going to reassign it to 0. Okay, not a problem. Console.log counter, so print 0, and then it increments by 1, so it's 1 now. And then it comes up here, is 1 less than 10? Yes, it is. Oh, okay, let counter equal to 0. Reassigns it to 0. So this just prints 0 many times, as you can see from here. Whoop. Yep, many times. So that's why you always have to put the counter, if you're using a while loop like that, and really you should just use a for loop. That's kind of why you declare instantiate the counter outside the while loop. It's because of scopes. So take a look at the slide. Each binding has a scope, part of the function in which the binding is visible. So functions have a scope too. Functions can have bindings within their function block, just like while, like that while loop, within the block, within those curly braces. Any variables that are created, bindings that are created in there, you're not going to be able to call them outside of that loop, outside of those curly braces. Because that's the block, that's the scope that it's used in. But now stuff outside of the block, bindings outside of that block, they can be used outside of the block and inside the block. Those are kind of like global variables. Look at that second bullet point there, where the scope is the whole program, right? So the scope is not just within that block, that function block or whatever. The scope is the whole thing. The whole program has access to it. So function, sample function. We won't do a parameter in here. And then we'll return X. And let me see. So if we console.log sample function, what would this return? What would this return? And this is running so slow. So slow. What if I do this? No, clear this. Please clear it. Oh my gosh. Oh, I'm going to have to refresh this. But it should print 5 because of the global scope that the X binding here has. This can be accessed by anything within this file, even the function. Now, if you were to have let y equal to 5, right? And then you try to console.log y, like let's say you had in here, let y equal to 5. My gosh. Let y equal to 5, right? And then if you try to console. This is being just so. Then you try to console.log 5. See, I'm in a better mood now. This won't print 5 because the binding here is only relevant to the scope, to inside of those curly braces. So look there, local variables. Local variables is where the scope is confined to the function or block it is declared in. Remember the trick I used in the while loop. So in order for the counter to work, it had to be declared outside of the while loop like I showed you guys before. Hopefully, will this print something? So it didn't print 5. What about console.log 6? I think this code pen is just, honestly, just really acting. Oh, no. I'm going to have to find a better way to code with you guys because code pen, this is not. There we go. Okay, thank you. Thank you so much. Oh, I think I said it last time too. I'd have to use VS Code. What do you return? Console.log. There you go. 5. Okay, let's move on to the next slide. This is going to show a picture of scope here. So let me zoom in. There we go. So this is an example of nested scope. You have a function, foo. How many parameters does foo have? It has one parameter, x. Look at what's inside foo now. Look at what is inside the curly braces. You have var b equals a times 4. Then you have another function, bar. And how many inputs does bar have? 1. It's got one input, one parameter. And then you have another binding, var c equals y times b. It's going to return c. Does the function foo have any idea what var c is? Does function bar have any idea what var b is? So could you bring in b inside of function bar? Yes, you can. Could you bring c out into function foo? No, you can't. You could not do that. It goes kind of from top down. So you could use a inside of foo. You could use var a inside of bar. But to go from the inside out, you can't. You wouldn't be able to do that because of the scoping. So let's move on. What do we got next? Hopefully that makes sense for you guys, and if it doesn't, let me know if it doesn't. We can talk about it in the comments section. So how do we create functions? So the way that I was doing it here with sample function, this is one way to do it. It's a declaration notation. It's where the keyword function is used at the start of the statement, and then the statement that defines the binding, and it points it to the given function. Doesn't require a semicolon after it, and it's not part of the regular top-down control flow. So I could put this function down here below where it's called, below the console.log, and it still returns, or the console.log still prints out 5. So I've seen this before in how people have structured their JS files, where they'll have all the functions, like the helper functions they have, they'll declare them like way at the bottom of the file, right? And then they're still able to call those functions up at the top. It doesn't follow that same top-down control flow of control, if you will. But there's 2 other ways to call functions, create functions that Recursion goes over. So one is functions as values. And this is where you have to understand that there's a difference between a function and its name. And you can assign a function to a value kind of like a binding. It really is like a binding. So think, let x equal to 5. That's our binding, right? You can do the same thing with functions. So let sample function equal function return x plus 5. So now console.log, let's say sample function, and let's give it 5. So it's 10. So see, you assign a function declaration. That's how I'm going to say it. You assign a function declaration to a binding value, right? So slightly different. I'm just curious, what would happen if I did this? I don't think anything would happen. Sample function. Oh, okay. So the sample function binding houses what the function is. That's funny. So it prints off literally what the function is there. But to actually call the function, like invoke it, you have to bring about the parentheses here. Oops. With the correct number of parameters. So, yeah, not a number. 11. Okay. So another way to create functions is using arrow functions. Arrow functions are where you have a parentheses. It's basically just a shorter way to write a function. I think it was introduced, let me see, because Recursion talks about when it was relatively later on. Arrow functions were added in 2015, mostly to make it possible to write small function expressions in a less verbose way. So as you can see, there's the formula there in the PowerPoint on how to write arrow functions. You basically have the parentheses where the parameters are with the arrow, so the equals greater sign, and then the body is still within the curly braces. So if I was to write sample function as an arrow function, instead of this function keyword, maybe you do this. And as you can see, that console.log here still prints off 11. So just a slightly different way to write it, and you still assign it to a variable here, right? And I've heard that if you have only one parameter, I don't even think you need the parentheses. Let's see what happens here. Okay, maybe you still do. Maybe it was if... Was it this? No. Okay, never mind. I'm sorry, guys. I thought it was if you only had one parameter, you didn't need the parentheses. I guess always... And I do this normally anyway. I always have the parentheses and then the parameters within the parentheses there. So this is an arrow function. So you could have multiple parameters in here, right? X plus, let's do X plus Y plus 5. So what if I have this? 6, we added a new parameter. We added a parameter to the function call where we're invoking it. So we have 2 parameters in there, 6 and 6. So 6 gets assigned to X, 6 gets assigned to Y, and then we're returning 6 plus 5, which is 17. 17, okay. So that's how we create functions. And I think there's other ways too, but this is just kind of what Recursion went over. Next, we go to the call stack. So in Java, we learned about collections, and there is one such collection called a stack. And there's others too. There's a queue. There's a stack. There's a linked list. There's an array list. There's all kinds of different collections. And a stack, think of it like a pancake stack, I think is the best way to describe it. That's how it like stuck in my mind when my instructor was teaching me about this. A pancake stack, how do you eat from the pancake stack? Well, you eat from the top you take from the top stack and then you put it on your plate, right? Unless you have a huge stack and you just cut right through it. Okay, we know the gluttons out there. Okay, fine, they'll do that. But you take from the top, right? So it's the last pancake on the stack is the first one out. Right? For all the accountants out there, LIFO, FIFO, and LIFO, last in, first out. And that's kind of how functions work, or how like basically your code works. The call stack is where the place where the computer stores the context, or like the place where it's at in the execution. Every time a function is called, the current context, let me scooch over here, the current context is stored on top of this stack. And it's last in, first out. So the last function to be called is going to be the first one out of that stack, the first one that is executed. This is from the JavaScript documentation, so from the Mozilla MDN. I have a sample of it right here. And look at that. There's my call stack definition that I'm quoting over here. But the MDN web docs, that's where I used this from. And then, yeah, that's where I used that image from. If you guys were so wondering where I used that image. Where's CodePen? There we go. So from the MDN docs, a call stack is a mechanism for an interpreter, like the JavaScript interpreter in the browser, to keep track of its place in a script that calls multiple functions. What function is currently being run and what functions are called from within that function, etc. So when we invoke a function, it's added to the call stack. Once that function is finished executing, it is removed from the call stack. Okay. Does that make sense? Hopefully that makes sense. I'm trying to think. Okay. Let me see if I can demonstrate this for you guys here. Right, so we have this, right? And then we're going to do, let's do another function, second function. What is this called again? Declaration notation, very good. X, Y. We won't return anything here, and we'll just have a side effect. We'll console.log x plus y. And I'm going to delete this. And it's going to save, and then let's put it back. Sample function. Six and six. Oh. Let's do this. We're going to create this second function outside of there. Some x and x. And then we're going to call it within, so second function. So second function x, y. Oh, I hope this works. There we go. Okay. Just for sanity's sake, I will clear that. I will take this out. CodePen's going to save. I'm going to put it back. Okay. Now let's see here. So 12 and then 17. So sample function is called, right? That goes onto the stack. That goes onto the stack. So that's on the stack right now, right? And then what happens in sample function? Second function is called, right? So that goes on top of sample function. Second function is called. It just prints, which is what it did here, prints 12. So that finishes running. This is taken. This is taken off the stack, right? Then it comes down to the return, right? The return is going to return x plus y plus 5. Here, this is where it's being called, right? It returns x plus y plus 5, which is 17, and it prints 17. And then this gets removed from the stack, and it finishes running. So just think pancakes. I know, don't get hungry. Just think pancakes whenever you think of the call stack. Last in, first out. Next, optional arguments. This was interesting, and this is something that I never knew about JavaScript. When you're defining a function with a certain number of parameters, if you do not supply the correct number of arguments, JavaScript has a way to handle this. So let's use a sample function again. So it's got 2 arguments there. If you pass in too many, the extra ones are ignored. So if I'm printing the call of sample function here, 6 and 6, right? This was printing 17. We saw that. What if I have 8 here? What if let me clear that and let me do this again. Wow. It still prints 12 and 17 because I've only defined this function to have 2 parameters. So the extra one gets ignored. But now what if you pass in too few? Right? So what if I pass in just 1? What's going to happen? You get not a number because the missing ones get assigned a value of undefined. So implicitly, I'm going to use that word, implicitly, JavaScript handles the one that you did not supply as an undefined. So this y here is going to be assigned as an undefined. X is still going to be 6, but the y is going to be undefined. Hence, you get not a number here. And I never knew this too about JavaScript, but you can default values for functions. You can default the arguments. So let's take sample function again here. Let's say y equal to 2. You could do this. Now, let's see what happens here. If you don't supply it, it gets defaulted to whatever you instantiate it here as. So 2. So I did not supply a number here. I just supplied the 6. That's going to get assigned to x, but I did not supply the y. So since I didn't, it's going to default to 2. And what's 6 plus 2 plus 5? 13. And same thing here. This is going to get supplied a 2, so the 2 is going to be here. So 6 plus 2 is 8. Pretty cool, and I never knew that about JavaScript. I thought that was really, really nifty. Next, closures. Being able to reference specific instances of local bindings in an enclosing scope. So local bindings in a function are newly created in every call of that function. I'm trying to think of the best way to show this to you guys. This concept, I remember this concept from when I was learning Golang as well. And that's going to yell at me. How about this? How about let z equal 7? Okay. Now let's do this. Let's do 10. I'm going to clear it. We're going to take this out. It's going to save. Let's put it back. Let's see what it prints. Okay. Here's how, best visually I can describe what a closure is. So being able to reference a specific instance of a local binding in an enclosing scope. Enclosing scope is like these curly braces. They're defining the block. And you have local bindings and you have specific instances of the local bindings. So you have the local binding here, Z. It's being assigned to 7, right? And when you call, I'm trying to, you know what? You know, a better way to do this would be to say like this. This would be a better way to do this. Yeah, okay, there we go. So local binding Z is going to be assigned to Y. So whatever you supply here, right? Not going to be 2 anymore. It's going to be 7. Yep, okay, there we go. So Z gets assigned to Y, which in this case, this top function here is 7, right? And then we're doing X plus Y plus Z. So 6 plus 7 plus 7, which is equal to 20. Now, if you call sample function again with different parameters, you're going to be able to, this local binding is going to change. It's going to change because every time you call sample function, you're calling like a new like specific instance of it. So the local bindings in a function, look at that second bullet point, local bindings in a function are newly created in every call of that function, right? Because in the first one, Z was being assigned to 7. In the second one, because we're defaulting here, it's being assigned to 2. So that's really all what closures are. I thought it was, I remember having a really hard time getting this in Golang, but no, that's just what it is. You're enclosing the local scope. And a new local scope is created for every time you call the function. Okay, so moving ahead, let's talk about recursion. Now, this is a topic that almost should just have its very own video. And hopefully at this point, this video is not going to be too long for you guys, and I'm not going to go super in-depth with recursion because, again, it could be like its very own topic, its very own video. What is recursion? A recursion is where a function essentially calls itself. So if you look to the left, I kind of started this function, add to 0. What add to 0 does, and I probably should name this something a little bit better, but whatever number you input into this function, it's going to add up all the numbers from that number to 0. It's going to sum all the numbers from that number to 0. So, if you put in 3, if you guys see my comments here, if you input 3, it's going to add up 3 plus 2 plus 1, which is going to equal 6. If you input 4, it's going to return 4 plus 3 plus 2 plus 1, which equals 10. If you put in 2, it's going to be 2 plus 1, which is 3. And then if you input 1, it's going to be 1. Okay. So there's a way to solve this by running loops. And in general, loops, from what Mergen was saying in this chapter, loops are cheaper and faster. But with recursion, it might look a little more elegant and cleaner, maybe like a little bit less code. There are 2 resources I want to point you guys to that really helped me with recursion. One of them is this article, How to Think Recursively, Solving Recursion Problems in 4 Steps by Jack Chen. And we're going to talk about those 4 steps and kind of how I use the 4 steps that Jack lays out. There's also a YouTube video, Introduction to Recursion by CS Dojo. He's got like over 1 million subscribers on YouTube. Very good resource for anything coding related. I've enjoyed some of the videos that they have put out on CS Dojo. I would point you guys to those 2 resources for like a very in-depth like discussion on what recursion is. We're just going to touch base on it here. The 4 things that Jack talks about in the article are: 1, you got to know what your function should do. 2, pick a subproblem. 3, use the answer to the subproblem to answer the original problem. And then 4, a base case. The example I have over here in CodePen is a very, very basic example. And again, you can use loops to solve this, but we're going to solve it recursively. So what is our function doing? It's taking in a number, x. It's summing all the numbers from x in between x and 0. Okay. So what's a subproblem? Let's say you input 4. Let's say x is 4. So we're going to do 4 plus 3 plus 2 plus 1. The subproblem is, let's pick 3 plus 2 plus 1, right? So you know that in order to get to the answer, you have to take the answer to the previous number. So 3, look at here, guys. This is, and I love visualizing this. It's like a step ladder. 3 plus 2 plus 1 is the same thing as if you were to input 3, right? If x was equal to 3, which if you input that into the function is going to give you 6. What else do you need to do here, right, to get to 10? 6 is 4 less than 10. What's the number that you are inputting into the function? 4. So 3 plus 2 plus 1, right? Follow me here. This is from the previous number 1 less than x. X minus 1. And what are you doing to 3 plus 2 plus 1? You're summing it all together. What is the function doing? Add to 0. Summing it all together. So you could kind of break this down by saying, instead of saying 3 plus 2 plus 1, what could you say? Add to 0, taking in 3 as a parameter, plus 4. Are you following me here, guys? Essentially, you're breaking this up into a subproblem, just like this one. Look at this, 3 plus 2 plus 1. Add to 0, input 3. It's going to give you 6, right? Go 1 less than that. Add to 0, input 2. That's this one. Where else do you see this pattern? Here. So you could say here, this is 3 plus add to 0, 2, right? I'm sorry, 3 plus add to 0, 2. Do you guys see that this is kind of similar to that? Add to 0, 2 is this one. It's going to produce 3. 3 plus 3 is 6. Do you kind of see how this is all being put together? Now use that subproblem to solve the original problem. That's kind of what we're doing here. Here's the subproblem. We're solving the original problem here. This is solving the original problem. This is the subproblem. Now we need to have a base case. So the base case is something that is like the constant. If you input 1, what is 1 plus 0? It's 1. So we're always going to know that add to 0, 1 is 1. And I guess, too, you could have base case. You can have, all of these could be base cases, right? Because this is relatively like pretty easy addition here. So yes, we're going to know if you add to 0, 2, it's going to be 3. If you know add to 0, 3, it's always going to be 6. But it's not always going to be the case, especially if you do very complex functions. Okay, so you have the base case is like the constant. The base case is the thing that's going to return an actual number. Otherwise, you're going to return the function manipulated. How are we going to write this out, guys? How are we going to write this out? Well, how do we write this out? It's taking an x plus add to 0, x minus 2. So add to 0, x minus 1 plus x. You follow me? So console.log, add to 0. Let's pick something easy, 3. And what's going to happen? And we're not going to be finished yet. I will say that. And let me do this. Let me clear this. Now let me put it back. Let's see what this prints. I think it'll... Nothing. Okay. Nope, that is A-okay because we didn't add our base case in here. So let's have two base cases, 1 and 0. So if you add everything from 1, between 1 and 0, it's going to be 1, right? So if x is equal to 1, you know that the sum of that is 1, right? So we're going to return 1. Else if x is equal to 0, well, what's 0 summing everything from 0 to 0? It's 0. Does that make sense? So now, let's say you input 4, right? Think about the call stack. Is 4 equal to 1 or 0? No. So we're going to return add to 0, 4 minus 1 plus 4. So add to 0, 3 plus 4. So now, I hate when it zooms like that. There we go. Now it's add to 0, 3, right? So that gets added to the call stack here. 3. Is 3 equal to 1? Is 3 equal to 0? No. Comes down here. Return, add to 0, 3 minus 1. What is that? 2. So now it's going to go to the call stack again. Add to 0, 2. Is 2 equal to 1? No. Is 2 equal to 0? No. Add to 0 equals 2 minus 1. Add to 0, 1 is now being added to the call stack. Add to 0, 1. Is 1 equal to 1? Yes. Return 1. Now it's going to start going back through the call stack into all the other pancakes that you just called, that you just added onto to the stack. You see where I'm going with this? What gets removed from the stack next? 2, right? Add to the 0, 2. What is add to the 0, 2 is going to involve 1, which you returned, right? Plus x, which is 2. So now you know, now you have a sum. Now you have something that's being added to the sum, 2. Right? Then you're going to go back, add to 0, 3. Add to 0, 3 is add to 0, 2, which we just solved for. It's here, it's 3. And you start going back, flipping through the pancakes, taking them off the stack. So I'm wondering why this didn't call, though. I'm going to remove this. It's been a while. I'm going to refresh CodePen. So you see how important the base cases are. The base cases are for when you need to return the concrete value. It's when the function calls itself to a point where it returns a concrete value. And then that concrete value is then used to go, oh, not today. The concrete value is then used to then go back through the call stack. And so you get 6. Look at that, guys. That's what we want. What if we did 4? Well, we should see 10. 10. There we go. And this is the solution right here. Again, honestly, I probably would still just still loop through this. But you see how you can solve this by calling the function. Know what your function should do, right? our function should add everything from x to 0, pick a subproblem, right? Subproblem, right? Use the subproblem to solve the original problem, right? I feel like I'm saying right too much, but subproblem is used to solve the original problem here. And then have a base case. What's your base case? 1, 0, stuff that are like concrete that you know are true. And just believe in yourself. I think I was reading that in one of these articles about recursion. Is just sometimes you just got to believe that the code is going to do what it's supposed to do. Now you gotta have ability, and it is on you to write good code, but believe in this, and believe in this part, that this works. Does seem kind of magical, but it works. Sorry if I went through that fast or if anything wasn't clear. If you guys have any questions, please put them down in the comments section. Growing functions. So what did Merge and Haverbeek mean by growing functions? Well, functions come about by two different ways. So it's either you find yourself writing a similar piece of code multiple times, or you need to add some functionality to something. When you make those additions, that's when your functions can grow in scope. And definitely they would change. Maybe sometimes they don't really grow, as in like they get bigger, like more lines of code. Maybe they get simpler, right? But the writing similar code multiple times, I don't know, maybe if you have something like this, let x equal 5, console.log 10 plus x, console.log 11 plus x, console.log 12 plus x. That is very strange. The console is not working. Let me see. I'll probably have to refresh. So you can see what I'm doing here, though. So initializing, declaring a variable x, and then we're just adding x to certain numbers here, right? This is a very basic example, guys. So I could have probably come up with something maybe a little bit better, but you can see that you're kind of repeating the same thing here. You're taking in a number and then adding 5 to it, right? So how could you maybe save yourself a little bit of time? Function add 5. And this add 5 is going to take in a parameter, and you're going to return x plus 5. So now, you don't have to say console.log 10 plus x. You could say console.log add 5. We're going to call the function, and then whatever you want to put in here. You want to put in 12. Let's see, we get 17. That printed off. So, this is kind of one way. If you see yourself like repeating this addition of x, which is really just 5, then you move it to a function, and you call the function, and you just pass in whatever number you want 5 added to. Okay, so what about adding functionality to this? I'm trying to think of like an example here. Okay, I might have one. It prints the number. We're going to return the number, but we want to return it, and this is kind of similar to the cow and chicken problem in Eloquent JavaScript, where a farmer says he has like this number of chickens, this number of cows. you make a function that would print off like, oh, you have this many cows, this many functions. And then to demonstrate like a growing function, like adding functionality to that function, lots of functions being thrown out at you guys right now. The farmer requests that he is also adding pigs to his farm. So now he wants you to print off the count of cows, chickens, and pigs. So now you kind of have to adjust your function based on what you're passing in. Are you passing in numbers for pigs or cows or chickens? Right? So the function changes a little bit. I'm trying to think here. Let's say we don't just want to return the number x plus 5. We want to return it in a 3-digit format. So if we're printing 17, here we would want it to print 017. Okay, so what do we have to do here? What are we going to have to do? Whatever number is being passed in, I think this x plus 5 would still work. Maybe let's call it sum. Let's assign it to a variable sum. And it's returning undefined, which is it should because it's not returning anything. So remember, we talked about that a few slides ago. So we need to do a check here, and we need to do a check and see if it's how long is this number. If the number is less than 3 but greater than 1, then we're going to add 1 0 to it. But if it's less than 3, or if it's less than 2, if it's less than 2, we're going to add 2 zeros to it. Okay, so we kind of have our plan here. If less than 3 but greater than 1, add a 0. If less than 2, add 2 zeros. Okay. So we're going to need to do a check. So if, else if. Now, how can we check length here? And I wonder if this would do anything. Return 0 plus sum. And it's going to typecast this, but I wonder how it's going to do it. So 017. Okay. That's actually, you know what? I'll take that. It's in string format, which is okay. So let's try this out. So if sum is less than 3. What's another way to say less than 3? What's another way to say less than 3? 3 is like if we had the length property of a string. If it's less than 100, there we go. So if it's less than 100, or pipes, or if if it's less than 100, okay, if it's less than 3 and greater than 1, there we go. And if sum is greater than the tens place, so if it's greater than 9, so everything between 99 and 10, all inclusive, right? We're going to return, we're going to return the statement, this expression statement. Return 0 through 100. 0 plus that. Yep. But else if, now we have to check for, now we have to check if it's just a single digit. So if it's something less than 10. Else if sum is less than 10, okay, we're going to return 0, 0, 0 plus sum. And if not, if it doesn't, if none of these match up and it's greater than, else we're just going to return sum. There we go. And it prints off 17. So you guys see what I did there? So the goal here is adding trailing zeros. And the zeros, preliminary zeros, not trailing, so leading zeros. There we go. Adding leading zeros to a number if the number is less than 100. We want to fill the hundreds place and the tens place with zeros if at all possible. So you can see how this works for 12. 12 plus 5, 17. We're going to return 017. Now, here's the thing. That's a string. If we wanted to return an int, I wonder, is this possible? I don't know if this would be possible, if this would even work. Because I know this is how you can convert to a string. Int is not defined. Number? Oh, cool. Okay. Well, that worked. Okay. So, because, yeah, the number is, you convert it to a number, but it takes away the 0. So I don't want to do that. I want to show you guys what, I want to, test this for not just 12. Let's do something bigger. Let's do something smaller. Let's do 3. Let's see what it prints for this. 008. So 3 plus 5 is 8, right? Is 8 less than 100 and greater than 9? No. Is 8 less than 10? Yes. So we're going to print off 008. What if we have something greater than 100? So let's say we have 101. What should this print? It just returns the sum. Exactly. Oh, and I don't convert it to a string, so it literally returns the int. So you can kind of see there how we started off just returning x plus 5, the sum of x plus 5, and then as the specifications change, and maybe this could happen on like a team that you're working on, or just you like enacting some added functionality that your code needs to reach. So you grow the function. Look at it first started from here, and now we've got some if-else branching here that is returning the sum with leading zeros if necessary, if the number is less than 100. So if you guys have a copy of Eloquent JavaScript, take a look at that cow and chicken problem. It's definitely a little more, there's more to it than, it's a little more code than like this example that I showed, this add 5 example, but you get the kind of gist of what growing functions are from that. Last slide. This is kind of something that we talked about, and this is going to be the last slide here. The two types of functions, those that are called for their return value and then those that are called for their side effects. So this add 5 definitely called for its return values. You can see there that we're returning something. And there's a return in each of those if-else branches. And if a return is hit in one of these conditional branches, then it exits the function. So if, other functions that we had, maybe they just print something, and that print is the side effect. Recursion introduces to this thing called pure functions. And pure functions are when a function is called and it has no side effects. And in addition to that, it does not rely on side effects from other code. So it doesn't read any global bindings. So I'm trying to think of an example of this. When called, they have no side effects. So you wouldn't print anything, and then you're not utilizing a global variable. An example of this could be a function that just returns RC. Now it. Yeah, okay. A function that returns a time. Like you have a function that's like get time. Right? And then whenever you call it, it just returns the current time at that moment, the system time. You don't rely on any global bindings. You don't have to do that. You don't have to print anything. So that could be a potential pure function. In Mergen, I think even goes into saying like pure. It's not like something you should strive for. It's like when I first heard of this, like pure functions, like, oh my gosh, like all my functions need to be pure and clean and like work properly. But that's not really what it means here. It's more like you shouldn't strive. It's not necessarily like pure functions are something you should strive for. It's more like just a matter of fact, like if it happens, you know what kind of function you have, basically. And guys, that's going to do it. That's going to wrap for Eloquent JavaScript Chapter 3. Thank you guys so much for listening this far. Let me know if you have any questions, guys. I know some of this stuff maybe I don't quite explain that great. Or maybe I do. Let me know what you think about the presentation. But if you have any questions, leave them down in the comments, and I'd be happy to work through stuff with you, or like touch base and talk shop, like work out some issues, some problems that you're having, or do the best that I could. We'll be back next week. I got to start this blog soon too. We'll have a blog companion to the videos, and just stay tuned. Super excited. Lots of big things coming down the pike. So thank you guys very much. My name is Chris. This has been Chee-Tash. Take care.